Here we're going to look at some examples on how to solve elementary logarithmic equations. So one of the things that you want to do is you want to be able to take advantage of some of the exponential rules that we have in place and properties that we have in place, which make solving your logs a little bit easier. And so if we look at this first example here, the first thing that we want to do is we want to rewrite into exponential, because then we can use some of those ideas. And so here, to rewrite it, says that this is going to become 16 raised to the 3/4 equals x. Now with that, we have to remember some of those exponential rules. And so those rules say that the numerator here is your power, and the denominator here is your root. And so in this case, what we would do is we would go ahead and use your exponential rule, which says that we can rewrite it So we're going to rewrite it so that we end up having the 4th root of 16, and then we're going to cube that to equal my x. And so that is the rational exponent rule that we are applying. And so then what happens is we're going to do what's inside the parentheses first. And so the 4th root of 16, well, this is going to become the 4th root of 2 to the 4th cubed is equal to x. And then here this means that you're going to have 2 to the 3rd, which equals x. So we have x equals 8. Okay. Alright, if we look at this next one, we can kind of do the same thing. And so here we would end up having 3 to the negative 2 is equal to 9 to the 2x. Now here we want to rewrite 9 as 3 to a power. So in this case we know that 3 squared is 9, so this is going to be 3 to the negative 2 is equal to 3 squared to the 2x. Now the other thing that we have right here is we have power to a power. So here we have 3 to the negative 2 is equal to 3 to the 4x. And then the very last thing that we can do is we can apply the property, which says if your first base to a power has the same base to a different power, then your powers equal each other. So in this case, my bases are both a 3, and so therefore we would solve that negative 2 is equal to 4x. So in this case, negative 1/2 equals x. Alright, now let's take a look at this next example. So here, the rule that we have to listen to is we need to rewrite your natural log as a log base e. So here we're going to go ahead and do that. We're going to rewrite this. So this says that the log base e of x plus 1 equals 3. Now we can go ahead and convert this over into exponentials. So what we end up getting is that e to the 3 is equal to x plus 1. So e to the 3 minus 1 is equal to x. And now in this case, I would leave this as is because this is going to be a decimal that has a lot of non-repeating values, and so leaving it in this form is exact. Now with this one over here, we're going to use the rule where we are going to raise each side to your e. So this becomes e to the natural log of x squared is equal to e to the 0. So when we evaluate, this part right here is going to undo each other. And so what we're left with is the natural log of x squared is equal to 1. We are then going to repeat it. So now we're going to raise both sides to your e. Again, just like before, my e to the natural log, this is going to undo each other. And so with that, what ends up happening is we end up getting that x squared is equal to 1. When we solve for x, we get x is equal to, sorry, not 1, this is e to the first. We get plus or minus the square root of e to the first. Okay. And so there you have it. We are using our exponential rules and properties in order to solve your logarithmic equations. So if you have any questions, please let me know. Otherwise, I hope you enjoyed this video, and I'll see you next time.